In our operating system series, in the last video, we saw how multiple processes run on a system, but so far, we treated processes as completely independent. Now let's look at a real situation. Imagine you are watching a video on your browser. What's happening behind the scenes? One process is downloading data from the internet. Another process is decoding the video. And another process is rendering it on the screen. All these processes need to work together. They need to exchange data continuously. But here's the challenge. Processes do not share memory by default. Each process has its own separate memory. So one process cannot directly access another process's data. This isolation is good for safety, but it creates a problem. So how do processes communicate? This is where inter-process communication, or IPC, comes in. IPC is a set of mechanisms provided by the operating system to allow processes to exchange information. Now here's the key idea to understand IPC clearly. All IPC mechanisms fall into two broad categories. Either processes share memory, or they send messages through the OS. Let's explore both. First, shared memory. Here, two processes are allowed to access the same region of memory. So instead of sending data, they directly read and write to the same place. Think of it like a shared whiteboard. This is the fastest method, because there is no copying of data through the OS. But there is a big challenge. Since both processes can access the same memory, they must coordinate carefully. Otherwise, they might overwrite each other's data. So shared memory is fast, but tricky to use correctly. Now let's look at the second category, message passing. Here, processes do not share memory. Instead, they communicate by sending messages through the operating system. The OS acts like a middleman. Now within message passing, there are multiple approaches. First, let's talk about pipes. A pipe is the simplest form of communication. It is like a one-way channel. One process writes data. Another process reads it. This is usually used between related processes, like parent and child. So pipes are simple, but limited. Communication happens only in one direction, and it's typically used between related processes. Now, let's move to something more flexible. Message queues. This is like a mailbox. Processes send messages to a queue, and other processes receive them. The OS stores these messages in between. So sender and receiver don't have to run at the same time. Compared to pipes, this is more flexible, because messages are structured and buffered. Now let's move to something more powerful, sockets. Sockets are more general. They allow communication between processes on the same machine, or even across different machines. So if you think about network applications, sockets are what make that possible. Compared to pipes and message queues, sockets are more powerful and flexible, but also more complex. Now let's look at something a bit different. Signals. Signals are very different. They are not used to send data. They are used to send notifications, like stop, terminate, or something happened. So signals are lightweight, but very limited. You cannot send meaningful data using them. Now let's quickly compare all of them. Shared memory is fastest, but requires careful synchronization. Pipes are simple, but limited to one direction and mostly related processes. Message queues are more flexible, because messages are stored and structured. Sockets are the most powerful, because they can work across machines. Signals are just notifications, not meant for data transfer. Finally, one important concept across all IPC methods: blocking versus non-blocking. When a process tries to read or write, it can either wait or return immediately. If it waits, it is called blocking. If it returns immediately, it is non-blocking. This choice depends on the application. So to summarize, processes are isolated by default. IPC allows them to communicate, and different methods exist depending on speed, flexibility, and complexity. In the next video, we'll explore file descriptors, how processes interact with files, devices, and even IPC mechanisms using a simple integer interface. We'll also see how concepts like input, output, and redirection actually work behind the scenes. So make sure you subscribe, and I'll see you in the next one.